In science, we encounter things that are massive and minuscule, that take a millisecond or millennia, and it can be hard to get your head around these different scales. This is not least because we can measure things that are well beyond what the human body can perceive. This activity is designed to develop a deeper appreciation of time and space scales, and through that, a deeper understanding of science. An oak tree like the one behind me is the focus, is the story that runs through all the different levels and helps us relate from one to the next. But don't mistake this for a biology activity. Let's hear what all of the scientists think when they look at an oak tree.
When I look at this oak tree, I think about all of the unseen chemical activity that's going on to make it grow. The structural material that holds this tree up is largely cellulose, and that's made up of lots of little glucose molecules. Those units are tiny, about half a nanometer from end to end. So it takes about 12 billion of them to go from the bottom of the tree up into the crown.
You may think this tree is old, but in fact it's incredibly young compared with the age of the universe. Although the tree is biological, there's a lot of incredibly interesting physics within it. For instance, huge forces hold up the trunk and the branches of the tree. The laws of physics govern the flow of fluid from the roots all the way up to the leaves to sustain life. And the chemistry of the cells in those leaves is governed by quantum physics.
I'm Dan Berwick, a molecular neuroscientist interested in the earliest events in Parkinson's disease. Looking at this tree, I can see it's affected by disease too. There are galls, strange structures caused by a type of wasp larvae. They're not unlike cancer. But when I look at the tree, I also think of all the compounds used in medicine. We call this tree the mighty oak because it's big and strong. But maybe the true power of this tree comes from the small molecules within.
I'm a plant ecologist and I'm interested in how this tree acquires resources and then what it does with those resources. So how it spreads out its leaves to get sunlight and carbon, how it spreads out its roots to get water and nutrients. How does this change across its lifetime of hundreds of years? And how did this evolve over millions of years? And how this species differs from other species to make it the enduring species it is today.
I study highly excited atoms using lasers and magnetic fields. When I look at this tree, I see that it's also made of atoms. It's made of hydrogen, which was created in the Big Bang, but the heavier elements, such as oxygen and silicon, were made in the star which previously occupied this part of the universe. That star is long since gone. It's been replaced by our star, the Sun, which gives energy to the tree in the form of light.
The oak tree's seen the building of the Open University campus about 50 years ago, but way before then, about 10,000 years ago, its predecessors started to colonize the UK, following a long period of glaciation. The rocks beneath the soil are even older than that, about 165 million years, and were formed by the accumulation of mud on the seafloor. So to me, the oak tree and its environment is part of a big movie picture extending over many scales of time.
Hi, I'm a biological chemist and I'm interested in sugars and their function in disease. To me, this tree is a big pile of bioreactors, making sugars, building proteins, making molecules. In the winter months, low temperatures change the properties of these molecules and the speed of these reactions. Whilst in the summer months, the leaves harvest energy and use this to build molecules. And every year, energy is captured by the leaves and stored as sugars and starches for the following year.
I'm a neuroscientist. That means I'm very interested in understanding how the millions of cells of the nervous system work together to allow us to do the things we need to do to live. When I look at this oak tree, I think about how similar and how different it is to us. Just like us, this oak tree needs nutrition, it needs water, and it needs to exchange gases with the environment, such as carbon dioxide and oxygen. It has parents, it has children, and unfortunately, it too will die. However, unlike us, the oak tree isn't exactly renowned for its ability to move. Unlike us, the oak tree can pull off one of the greatest tricks of biology, photosynthesis.
Every scientist sees this tree very differently, and that's because the tree is a product of the evolution of life, of the history of the universe, the history of the earth. It's a potential source of medicines, it's a pile of bioreactors, it's an organism that interacts with its environment. And this amazing tree is perfect for exploring scales in space and time.